Now that we have seen higher dimensional line and how to write their equation, let's now talk about a plane as well. So let me just pop one up here. So now we are looking at a three-dimensional plane, and you can kind of see this plane it's in the 3D space. So this is what a plane in higher dimension look like. And now the problem is, well, how can we describe this thing mathematically? How can I write out the equation for this plane in higher dimensional space? We are going to talk about two ways that we can do this. The first way that we can talk about, that we can describe the equation for this plane, is to first look at its normal vector. So let me now just pop out its normal vector. So its normal vector is the black vector that you can see here. So the normal vector is going to be a vector that is perpendicular to the line in the three-dimensional space. So you can kind of see this black vector is it points out of the line and it is perpendicular to the line. So let's say if I move this black point around, so you can kind of see how my plane moves relative to this vector. So this vector, again, this is called the normal vector. It's a vector that is perpendicular to the line. I mean to the plane. And so one way that we can write out the equation for this plane is to look at its normal vector. So a normal vector of a plane is just a vector that is perpendicular to the plane. So if my normal vector is a vector ABC, then the equation of the plane is going to look something like this. It is going to be A times X, B times Y, and C times Z. So my ABC here, this is just the coefficient from my vector, and my X, Y, Z here, these are my variables. So my X, my Y, and my Z, these are my variables. So we are talking about three-dimensional plane. So now my there's gonna be three variables of X, Y, and Z here, and then my D is another constant. So let's try to do this in the example that we have down here. I'd like to find an equation of the plane that passes through 1, 2, 9 and is perpendicular to 1, negative 2, and 1. So if I were to try to sketch this thing, let's say my point is this little guy here, so 1, 2, 9. And then I would like my plane to be perpendicular to 1, negative 2, 1. So it's kind of hard to draw this thing in 3D. So for now, let me just put out a vector here. So let's say this guy is 1, negative 2, and 1. So I would like to find the equation for a plane. So let me try to draw that here. So let's say this is my blue plane. My blue plane here is a plane that is perpendicular to the pink vector. So this is a little hard to draw in 2 dimensions, but you can visualize this being the case in the 3D space. So how can I write out the equation for this blue plane? Well, there's a number of ways we can do that. So let me actually do the hard way first. So let's say if I have a point X, Y, and Z on this blue plane. So my point X, Y, and Z is on this blue plane. Then I can have this black vector here. So my black vector starts from 1 to 9 and goes to X, Y, Z. So my black vector here, the coordinate is going to be X minus 1, Y minus 2, and then Z minus 9. Now, because I knew that the pink vector has to be perpendicular to the plane, so what that means is the pink vector has to be perpendicular to the black vector as well. And when the two vectors are perpendicular, that means their dot product has to be 0. So if I compute the dot product of this black vector here with 1, negative 2, and 1, this product has to equal to 0. Okay, so let's try to do this. If I compute the dot product, so I'm going to multiply x minus 1 to 1. So this is going to be 1 times x minus 1 plus negative 2 times y minus 2. Negative 2 times y minus 2 plus 1 times z minus 9. 1 times z minus 9. this has to equal to 0. Now I can just compute this out. So I'm gonna get 1x minus 1. So I'm gonna get 1x minus 1. And then minus 2y plus 4 minus 2y. Minus 2y plus 4. And then plus 1z minus 9 plus 1z plus 1z minus 9 equal to 0. I have 9 plus 9 equal to, wait a minute, this is not 9, this should be 1. I have negative 1 and negative 9, so that adds up to negative 10, and 4 minus 10, that is going to be negative 6. I move negative 6 to the other side, so I'm going to have that 1x minus 2y, and then plus 1z has to equal to 6, plus 1z has to equal to 6. So now here is my equation for the blue plane now. Notice how whenever we have the equation for a plane, I can actually just read off the coefficient from x, y, and z, and that is going to be just my normal vector. So the 1, negative 2, and 1 here, this is exactly the coefficient for x and y and z that we have down here. So this is one nice thing about the equation for a line in this form. Now, let me also do this another way. Because I knew that I would like my plane to go through 1 to 9 and perpendicular to 1, negative 2, and 1. So I knew right away that the coefficient for x, y, and z here is going to be just 1, negative 2, and 1. So I can kind of use this fact and just write out the equation for my line. So it's going to be ax plus by plus cz equal to something, let's say it's d. And my a, b, and c here is going to be just this coefficient here. So it's going to be 1, negative 2, and 1. So I'm going to have 1x minus 2y plus 1c equal to d equal to something. So it's going to be, let me just write x minus 2y plus c equal to something. So now I only have to find out what is the value for this d is. Well, how do I find out what is this d? I knew that my plane has to pass through 1 to 9. So what that means is I can plug in 1 for x, 2 for 9, and 2 for y, and 9 for z to compute what is the value for d. So if I do that, I'm gonna have that 1 minus 2 times 2, and then plus 9. That has to equal to d, but this guy also equals to, 10 minus 4, so that's a 6. So my d is equal to 6. So that means I can write out the equation for my line, and that is going to be x minus 2y plus c equal to 6. So this is the same equation that we have obtained from earlier.